Hi viewers, this is Arun. In this video, I am going to tell you about vandegraff generator. Please subscribe my channel to get more videos. So, vandegraff generator is a machine that is used to generate very high voltage of the order of millions of volt. So, when such high electric field is created, it is used for accelerating charges like electrons, neutrons, etc. So, let me explain you the principle in which a vandegraff generator works. Okay. For that, let us consider a sphere, a metallic sphere in which a charge Q is there. So, a large metallic sphere which is having a charge Q. So, when we apply a charge Q on this metallic sphere, it will be evenly distributed. And we are introducing another one small sphere with same charge, and it will also have a positive charge over that. Now, if you consider the large metallic sphere, now I am having positive charge on that, and what happens is above this metallic sphere, field will be there, but inside the metallic sphere, the field vanishes. So, outside this metallic sphere, field is there, inside the metallic sphere, no field is there. I am speaking about the field E. Now, I am going to find out the potential of the metallic sphere. Consider the radius of the metallic sphere as R. The outer metallic sphere radius is capital R, and the small sphere is having a radius small r. So, as I have told you, I am going to find out the potential of the metallic sphere. So, it will be V of R. So, V of R is equal to, we know the potential formula is Q divided by 4 pi epsilon naught into the distance. So, the potential of the outer sphere is Q divided by 4 pi epsilon naught into capital R, that is the radius of the outer sphere. But this outer sphere is acted upon by two potentials. One is itself potential, and another potential is due to this small sphere. I have told you that the electric field outside the sphere is a finite value, but inside the sphere it vanishes. But potential, in the case of potential, that is V is a potential. Outside the sphere, potential will get reduced with distance, but inside the sphere the potential remains constant. So, V remains constant inside the sphere, but E vanishes inside the sphere. Now, if you consider the potential at this point on the sphere, this sphere is acted upon by two potential. One is itself potential, and the other potential is due to the small sphere. So, consider the small sphere is having a charge Q, and the total sphere, total potential on this outer sphere can be written as Q divided by 4 pi epsilon naught into R, that is the potential of the outer sphere, plus small q divided by 4 pi epsilon naught into capital R. What does this mean? This is the potential of the small sphere at this distance, right? What is the distance? Capital R. So, this is the potential on the surface of the large metallic sphere. And what about the potential on the small sphere? In the small sphere, it is also acted upon by two potential. One is the potential of the large sphere, and the second one is the potential of the small sphere. So, what about the potential of the large sphere? The potential of the large sphere is Q divided by 4 pi epsilon naught into R. Plus, what about the potential of the small sphere? Now, the potential of the small sphere is having a radius small r. But in the previous case, we have considered it as capital R because we are finding out the potential at this distance, capital R distance. So, here we will get Q divided by 4 pi epsilon naught into small r. So, this is the potential at this small sphere. So, now which sphere is having more potential? Small sphere will be having the more potential because it is having the potential of itself plus the potential of the largest sphere. But if you consider the potential of the largest sphere, it is having both the potential, but what about the potential of the small sphere? The potential of the small sphere get reduced as the distance increases. So, the potential on the larger sphere is large. So, if you find out the potential difference, that is V of R minus V of capital R. Since we are having more potential over here, I am finding V of R minus V of capital R. So, that will give you the answer as Q divided by 4 pi epsilon naught into R plus small q divided by 4 pi epsilon naught into capital R minus these two values, q divided by 4 pi epsilon naught into capital R minus q divided by 4 pi epsilon naught into small r. Now this value and this value will get cancelled. So your final answer will be 1 divided by 4 pi epsilon naught into here q divided by capital R minus q divided by small r. So that is again equal to, you can take this q as common, q divided by 4 pi epsilon naught into 1 by capital R minus 1 by small r. So now this is the potential difference that is generated at this sphere. So now since the potential in the small sphere is greater than the larger sphere, if you connect this small sphere with the large sphere by means of a conducting wire, what happens? Charge will flow from the small sphere to the larger sphere. Can you understand it? So the small sphere is having more potential than the larger sphere. So when you connect a conducting wire from the small sphere to the larger sphere, what happens is charge will flow from small sphere to the larger sphere. When I am connecting a conducting wire from the small sphere to the larger sphere, what is happening? The positive charges will go to the larger sphere and it will accumulate over there. Thereby it is creating large potentials, and this is the principle by which a Van de Graaff generator works. So what is happening is, so I am connecting a conducting wire to carry the charge from the small sphere to the larger sphere. That is necessary. So if I find some setup so that I can transfer the charge from one place to another, I can be able to generate a large potential. And that is the principle behind which the Van de Graaff generator works. Now I will be telling you about the parts of the Van de Graaff generator. Here we have a pulley, two pulleys here. It is motor driven pulley, and in which the belt is made up of rubber or silk, an insulating material which can get charge on that and it can transfer to the larger metallic disc. So here we have a larger metallic disc over here in which the charge is accumulated. So what is that charge? The charge that is of the order of millions of volt is created on this large metallic sphere. So here we have a metallic brush by which we will supply the charge on the belt. So here we have another metallic brush by which the charge is transferred from the belt to the larger metallic disc. So I will explain you the principle by which it is working. So initially what we will do is, so these two things are the insulating support in order to support the large metallic disc. So initially we will supply the positive charges on the belt or on the conveyor, by which the charges are going to the other side, and another metallic brush is here by which the charge will be transferred to the larger metallic disc. So what happens when it continuously happens, the charge will be accumulated on the larger disc and it creates a large potential. So how much it will create? It will create till it reaches the breakdown potential of the air. The breakdown potential of the air is given by 3 into 10 to the power 6 volt per meter. This is the breakdown electric field value for air, and up to that it can get charged. So what is happening? It's very simple. Van de Graaff generator, this is the principle by which it is working, and here we are supplying charges, and these charges are conveyed by means of a belt, and it is then supplied to the larger disc. Thereby it gets accumulated by charges so as to produce a large field. And here we can make voltage from 6 to 8 million volts, or when it reaches the breakdown field of the air, it breaks down. So that much amount of charge can be created, or that much amount of potential voltage can be created by means of the Van de Graaff generator. Thank you for watching. Please subscribe us for getting more videos. Thank you.